Okay, so today we're going to learn how to write equations of quadratics given a vertex and a point. And you've actually seen this in the absolute value unit, but I think we showed it to you and then showed you a couple of different ways to get around it. But now we're going to learn the math. And again, you will not have a calculator on this test, so you need to make sure you learn how to do this. I want to write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. So this is my given vertex, this is my point. The first thing I'm going to do is I'm going to write down what vertex form is. Vertex form is y equals a x minus h squared plus k. And we've been using it so much that you should know that at this point. And then what I'm going to do is I'm going to go to my vertex and my point, and I'm going to label them. I know my vertex now is is hk. Okay, and my point is just a random x and y. What I wanted you to do now is just to notice, if I plug y in here, and x in here, and h in here, and k in here, the only variable I'm missing is a. In order to get quadratic function in vertex form, I have to have the a value. The a value is going to tell me if it opens up or down, if it's stretched, expanded, or compressed. So I'm going to go ahead and plug in my h and k and my x and y. So I know my y is negative 27. I don't know my a. I know my x is 2. I know my h is 5. And I know my k is 0. And so now I'm just going to solve for a. So I have negative 27 equals a negative 3 squared plus 0. And I don't really need that plus 0 at the end, so I'm just going to erase it, because adding 0 to anything doesn't change anything. Okay, this is going to make this negative 27 equals negative 3 squared is 9, and I'm just going to write that correctly. You could write a9. It's going to mess you up in the future when this number over here is not 0, so I would also say that mathematically this is not correct. I always write the coefficient and then the variable. So now we all know what to do. What do? We divide by that 9. And I'm going to get that a equals negative 3. So now if I want to write vertex form, I have my vertex and I have my a. So y equals, I just found out that my a is 3, x minus, remember I'm going back to my vertex, h and k, x minus the h squared plus k. And again, I don't need to write that, so my final answer would be this. All right, what if the numbers were a little scarier looking like this? Again, first step is to write down the equation, and you can write that in your notes. The equation is y equals a x minus h squared plus k. And again, I just want to remind you that this is squared because we are writing a quadratic function. If this were an absolute function, I would not have this squared, I would have absolute value bars. So this is going to look almost exactly alike for each function family, just adjusting for the type of graph it will be. Second step is to label my h, my k, my x, my y. And I would like you to write those directions in here. So this one says write down the vertex form. This one says label your h, k, x, and y. The third step then would be to plug in, and I want that to be black. So that would be to plug in to the equation. So y equals a times x minus h squared plus k. Fourth would be follow PEMDAS and solve for a. So I'm going to get 4 equals a. 2 minus 3 halves is 1/2 squared plus 25 over 6. I'm going to square that 1/2, and if I leave it, 1/2 times 1/2 is 1/4. If I leave that 1/4 right there, it's going to look like my next step is to add those together, and that's why I don't want you to do that. I want you to square that 1/2 and put it in front of the a, because I want it to say 1/4 times a plus 25 over 6. I'm going to subtract the 25 over 6, and I'm going to get negative 1 over 6. So if you need to write a note there, what did I do to get to this next step? And then I'm going to multiply everything by 4 to get rid of that 4. And I'm going to get a equals negative 2/3. Okay, this will end up being a equals negative 4 over 6, which will simplify to negative 2/3. So now my final answer is y equals a times x minus the h squared plus the k. And that would be the end of that one. Everyone should have gotten a worksheet of 7 word problems, and this is actually number 6 on that, underneath where it says challenge thinking ahead. This was given to you as homework to work in class and to look at overnight. So I'm missing some letters over here. This is flying fish. Okay, so I understand I'm missing some letters. This says flying fish, this says feet, this says the fish leaves the water, and this says solve for A. Okay, so I'm going to read this real quick. Flying fish use the pectoral fins like airplane wings to glide through the air. Suppose a flying fish reaches a maximum height. Oh, there's a word. I want to make sure I write that. I know maximum is an important word. Of 5 feet after flying a horizontal distance of 33 feet. Write a quadratic equation that models the flight path, assuming that the fish leaves the water at 0, 0. So just like last night in the word problem, I'm first going to draw a picture here. Okay, this is my y-axis, which is height. This is my x-axis, which is distance. And it says, here's my fish flying. He leaves 0, 0, and he flies through the air. It says he reaches a maximum height of 5 feet after flying a horizontal distance of 33. So this right here is my vertex. So there's my h and my k. So if 33, 5 is my vertex, I'm going to go ahead and label that h, k. I also know another point on here, because the fish leaves at 0, 0, that would be my point, x, y. So now, just like we did before, I'm going to write the equation y equals a x minus h squared plus k, and I'm going to plug in my h, my k, my x, my y. And I love that my x and y are 0, because we all know that 0 makes everything easier. A, x minus h, sorry, that should be 33, squared plus k. And I know that k is 5. Okay, and 33 squared is 1,089. So I get 1,089 times A. plus 5. Okay, this is negative 33. Negative 33 squared is 1,089. I'm going to subtract that 5 and divide by 1,089. And I'm going to get negative 5 over 1,089 for my A. It's a crazy A value, but I don't care how crazy it is. All I need to do now is plop it in the equation. Y equals A x minus the h squared plus the k. Oops, I don't know what I have against k this time. And I know my k value is 5. So now I'm just checking the reasonableness of my solution, okay? So I drew this picture. As soon as I drew this picture of the fish jumping out of the water, reaching that point and coming down, I know that this guy opens down. So my A better be negative, and it is. Good. If my A wasn't negative, I would have known that I did something wrong here over in my math. Okay, now this is very interesting. If you were to put this in decimal form, you would get negative, I'm just going to give you what A is in a decimal. It's approximately negative 0.00459, which is a very, very, very small fraction. Okay? So think about this. A is negative, but it also tells me what my stretch and compress is. That's a really big compression, which means this fish, if this is my water, this fish, the parabola is really wide, so he's flying a distance. Here he is. Okay, so he doesn't fly up in the air like this. That was terrible. I hit a wrong button, sorry. But he's not a stretch, so he's not stretched. It's not like he's flying really high out of the air. It's just that he's flying a long distance out of the air. And actually, we know how far he's flying, don't we? So I'm going to take it a bit further. This number here would be 33, which means if this is my axis of symmetry, then this number here also has to be 33. So this guy can fly 66 feet in the air. And that's something I would really like to see. I hope you guys have a nice night.